All right, so today we are going to be looking at the big idea of limits of a graph. Now, you've kind of encountered limits before when you talked about end behaviors of graphs. Remember doing end behavior a lot last year? You know, as this is getting close to here, you know, it's approaching infinity or whatever kind of thing like that. We're going to use some of those same ideas here when we talk about limits today. And so we're going to be introducing some newish ideas along with some new notation. So let's take a look at some of that. This is the sort of problem that we are going to be doing extensively today. So let's start by focusing just on this first one here and the notation that's involved with it. So what you're seeing here is it's saying, the way that I read it, is I actually read this as saying the limit, because LIM stands for limit, as x approaches 3. So that's what this x and the arrow mean, because it's x is approaching 3 from the negative side here. All right? And the limit always has to be of something. And so in this case, our limit is of f of x. F of x is just this big old graph that we're dealing with here. So that's going to be what f of x is when we actually go and do this work. All right, now, what does all this stuff mean as we start to put it together? When you write out any of these problems, the LIM for limit is always written slightly smaller and higher because you'll notice that the limit with the x part in there, it's about the same height as the f of x is. So the LIM has to be written slightly smaller and higher so that I have room underneath it to write the x and then the right arrow. Now if I just wrote this, the limit is x approaches 3. That would mean, what is the limit as x is approaching 3 from both sides? This will actually be the most common one you deal with. We just aren't going to be practicing that as much as from both sides here at the start, or individual sides here at the start, so we can get kind of comfortable with it, and we'll get more and more to where you're just doing it from both sides like that. When I put the minus up top there, that's now saying it's just from the negative side, just from the left side of that graph. And again, remember, it has to be of the f of x because it's telling us what it's actually taking the limit of. All right, so let's go back to our graph here. All right, so in our graph, I'm looking to see what is this approaching as we approach 3. So I'm looking for where the x is 3 here. And I'm looking from the left side. So I'm following the graph from the left side as it approaches 3. What number am I approaching right here? What is that y value? 2. And so that is actually the answer. The limit as x approaches 3 from the negative side is 2. Okay, now let's go for the next one. So take a look at the notation on the next one. It's the same notation. The only difference is that in this case, we have the little plus there instead of the minus. Kind of looks like to the power of plus, but of course we know it can't be to the power of plus because that doesn't make sense. So it's meaning from the right-hand side. So as I follow this graph from the right-hand side, I'm looking to see what happens as I approach x equals 3 again. I'm approaching this point. What is that point? What is that y value? 2. So it happened to give us the same thing from both sides. Since it actually gave us the same thing from both sides, that means I can actually answer this next question, which is just, what is the limit of f of x as x approaches 3? Because as it approaches 3 from both sides here, it was approaching the exact same number, so it is 2. Now, why is it approaching 2? Look at that last question, f of 3. If I plug 3 in here and look to see if x is 3, what is y? It is 2. So you notice all very similar ideas, right? Now this was a very simple example. This was for a point that's nice and clear, easy to see actually on the graph. But what you're going to find is that oftentimes when we're dealing with limits, we have to deal with limits because the points are not actually on the graph, or they are behaving oddly around this particular point. And so that's what we're going to start getting into more deeply. So this time, we're going to be going at 4. From the left, from the right, and then from both sides. Take a moment before we go through it here together. Think about what each of those answers would be. What would you expect each of them to be? All right, let's see what we've come up with here. So this time I'm looking at x equals 4, so I'm looking at that x value. So for the first one, the limit as x approaches 4 from the left-hand side. So as I'm approaching 4, what y value am I approaching there? 4. Okay, great. Okay, what about as we approach 4 from the positive side, that is from the right side? What number is it approaching? It's 4, right? So that's also approaching 4. And so when we take a look at that last question, what is the limit as x approaches 4? From both sides then? It is approaching 4 because it actually is reaching the same thing. Now what makes this question a little bit different though and brings up some interesting questions is, what about that open circle, right? Because this open circle here, what is it telling us? Well, what if I had asked the question, what is f of 4? F of 4 is nothing. There is no f of 4. It does not exist. But the limit is different from saying what is the value. The limit is saying what is it approaching as we get closer and closer to it. So you notice that as I'm approaching that value from the left-hand side, I'm approaching a height of 4. As I approach that from the right-hand side, even though I go up and then back down, I'm approaching a y value of 4. Limits are saying what's it getting really close to. It doesn't even actually have to hit it. It's just saying what is it actually just getting really close to. And that's why we're talking about limits here. You know, what's it getting near? All right, and now we're looking to see what's happening when x is 2. So I'm looking right along this value here. So the first one, the limit as x approaches 2 from the negative side. So I'm going along the negative side and I'm approaching 2, which is right here. What number is that approaching? 3. Okay, so the limit as x approaches 2 from the negative side is 3. Great. All right, what about on the right-hand side? So I'm following my graph along and I'm looking to see, as I get close to 2, what number is it approaching? 1. Now, in this case then, the limit as x approaches 2 then, well notice here, it's not from the positive side, it's not from the negative side, it is from both sides, and they're different numbers. When they're different numbers, that means it does not exist. Basically, like if you're tracing this side with one finger, and you're tracing this side with the other finger, if they don't meet up at that number, you cannot find a limit at that number. You can only find the limit from one side or from the other side, but not from both if they're not the same. And so in this case, it does not exist. Now, into some nitty-gritty little detail-y questions out of that. You notice that one of the numbers here, we had a closed dot there, and then below that, at the other point, we had an open dot. What did those affect? Absolutely nothing when it came to the limits. When it came to finding the limits, we're just looking to see what's it approaching. So the fact that I can actually find out, in this case, I could actually know that f of 2 equals 3. That doesn't change anything when it comes to finding the limits. Oftentimes, it can be tempting to think that that's going to affect this limit here. Because, oh, it's what is it actually at 2? Well, I'll look to see where the solid circle is. No, it doesn't actually matter. When we're talking limits, it's what's it approaching from the sides, not what is the actual value at that point. If you can do it one direction, you should be able to do it from the other direction as well. So here are a set of limits. What I'd like you to please do on your own paper is sketch a graph that meets all of those requirements. All right, so let's start putting the pieces together here. So the first part here, the limit as x approaches 0, so that tells me that this is happening at an x-coordinate of 0. I want f of x to be 1, so I want my graph to be at a height of 1 when x is 0. So I'm just going to put a little mark through there that I want it to approach 1 from both sides, because you notice the 0 here, it's not specific to just from the left side or the right side. It has to be from both sides that it's approaching 0. And then the next one, the limit as x approaches 3 from the negative side. So from the left side, I need the y value to be negative 2. So I'm going to go right 3 and down 2. And from there, that's what it needs to be approaching from the left side only. So I don't know about the right side there, but from the left side, it at least needs to be doing that. All right. And then from the positive side at x equals 3, my y value needs to be 2. So I go over to x equals 3, and it's going to be doing something to the right of it. Now, I don't know if it's going to be going down from there. I don't know if it's going to be going up from there. I don't know if it keeps going on forever. It doesn't actually matter, as long as we start at that point and then go off and do something from there. And then the last thing is that at f of 0, we need to have a y value of negative 1. So there needs to be a point there. It needs to be going through there, which could be potentially problematic if we don't deal with it right. Now those are all the things I know at the start. So now I need to figure out how do I connect them up and make them look somewhat reasonable. And you can do that in a multitude of different ways. So the first part there, the limit as x approached 0 was 1. So I just drew that little line through there. There's nothing to the left of it, so you could have it going down off to the left. You could have it be going up off to the left. You could have it, you could have it do whatever off to the left. It doesn't matter, as long as it's actually going through that, or actually I should say approaching 1 from both the left and the right there at 0. All right. Now the next point I have to deal with is going to be this one down here, where I knew that from the left-hand side, I'm approaching negative 2. So that means I need to connect up the graph between here and here. So I'm going to go ahead and change that slope a little bit and try to make it a somewhat pretty curve. All right, and then I jump to the next one where at 2, it then heads to the right. And again, it can head to the right by going down, up, whatever. It doesn't really matter. Okay, so I've got curves there, and then I still got f of 0 equals negative 1. Now there's a couple little other details that we need to take care of, though. Because you notice here, we're using this notation f of x. That tells us this thing has to be a function, right? So we got to tweak a few more things here to actually make it a function, because as I drew it so far, it's not a function. So first up, the first thing that we actually encounter when trying to make this a function is over here at 3. Because if this is going to be a function, I can't have a point here and a point up here. At least one of those has to be an open circle. So I'm going to pick one, and I'm going to make it an open circle. Now it doesn't matter which one you make an open circle here. I chose that one. Although the interesting thing is that in order for it to be a function, I can't have them both be solid. But I'm just approaching it from both sides, so if I wanted to, I could even have actually made the other one an open circle as well. So I could have done an open circle up here if I wanted to. That'd be perfectly fine, and it would still meet that requirement. Because there's nothing that says there actually has to be a point there. We just have to know that it's approaching those values from those sides. All right, and then the other one that's causing us problems here in terms of it being a function is at 0 here. When x is 0, we're told that it has to actually equal negative 1, but it has to approach positive 1. So the only way that I can make that happen, and this one we do have to do, is we have to put an open circle up here at a positive 1 to show that it is now approaching positive 1 from both sides, but when we actually hit 1, it's at the negative 1. And then that meets all of the requirements that were laid out for us in our original problem here. Next, we're going to take a look at limits that aren't nice, pretty numbers. So take a look at what we're dealing with here. We're going to do part A together. It's looking for the limit as x approaches 2 of r of x. And r of x is just our graph down here. So this is r of x down here. So when x equals 2, or x is approaching 2, what is r of x doing? What is the function approaching? Well, I'm going to go ahead and see here at x equals 2, so that's this line here. From the left-hand side, the graph is approaching, well, it's going down forever, it looks like. In fact, it is doing that. So from the left side, it's actually approaching a negative infinity. From the right-hand side, what's it approaching? Well, it keeps going down from the right side as well here. It is also negative infinity. Therefore, the limit as x approaches 2 of r of x equals negative infinity. Now, with that in mind, go do the rest of them. All right, so now on to the limit as x approaches 5. So I'm looking over here where x is 5. I'm looking to see what's the graph doing. So what is the graph approaching as x is at 5? It is approaching infinity, yes, from both sides. So that's why it's infinity. Good. All right, now, off to negative 3. Now, for part C, it's saying as x approaches negative 3 from the negative side, that is from the left side. So as I'm approaching it from the left side, what am I approaching? Negative infinity, yeah. And so that one equals a negative infinity. What about as I approach it from the positive side over here? What is it approaching? What is my height approaching? All right, and so then that one is approaching positive infinity. Now I'm going to give you a little side question here. What if I gave you this? The limit as x is approaching negative 3. What is just the limit as x approaches negative 3? Since at negative 3, our graph approaches different values. From the left-hand side, it's negative infinity. From the right-hand side, it's positive infinity. The limit at negative 3 does not exist. All right. And then last up, we're asked part E here to write the equations of the vertical asymptotes, just bringing us back to a little bit of practice and review for asymptotes. So let's take a look first of all at the asymptote that's back there at negative 3. So if I want to know the equation of this asymptote, it's the equation of the vertical line that goes through negative 3. If I'm going to write the equation of a vertical line, is it x equals or y equals? It is x equals, yep. And so it is x equals, and of course then, since it's at negative 3, it's x equals negative 3. So that's our first vertical asymptote. And then there's a vertical asymptote here at 2. That would be x equals 2. And then we also have a vertical asymptote over here at 5. That would be at x equals 5. So having done all of those problems, now it's time to figure out how do we do these just in general when we're just faced with the equation. We aren't given the graph and all that. And so you're going to make use of your graphing calculator here. When you're just given this, one way you can find the limit is by making the graph on your graphing calculator and then using that to answer it. So that's what I'd like you to do right now. So you plug this first equation into your graphing calculator, x plus 2 over x plus 3, and then you look at the graph and you see that as it's going from the left-hand side, and I want the left-hand side because notice it's negative 3 from the negative side. As I go from the left, is it going up or down? Should be seeing that, right? From the left-hand side, it starts climbing steeper and steeper. And so the limit as x approaches negative 3 from the left-hand side is going to be what? So it equals infinity. So the limit is approaching infinity there. What about the second one? As we approach this one from the right-hand side, which way is this graph going? Hopefully you're finding that this one is starting to go down very steeply. And so what is that limit approaching? Negative infinity. Now notice that as I asked both of those questions, I didn't even bother to ask what happened as we approached it from the right-hand side, because it didn't matter. Because both of these were from the negative side and from the negative side. That little thing that looks like it's saying to the power of negative is saying from that negative side, and so that's all we're worrying about with that. So what's happening from the right side doesn't matter because that part was specified.